Okay, so we are going to get into sequences in this video. So the main difference between sequences and regular functions is that sequences are discrete functions, whereas linear and exponential models are continuous functions. So discrete functions are sequences where each of the domain value is a distinct value, so separate values, as opposed to a continuous function, which is going to go on and on and on with no gaps in between. So linear and exponential were continuous functions. They didn't have any gaps in the middle. So if we look at a graph of this, it's going to look like this. Discrete is going to be individual data points on the graph. As opposed to continuous, you do not have to pick up your pencil to draw them. You can just trace them without picking up your pencil. Discrete, you have to pick up your pencil each time. So what we're going to get into today, sequences, are considered discrete functions. And that's a main difference between sequences and the functions we've been doing so far. So here is what a sequence is. It's a list of numbers following a specific pattern. So even as a kid, when you would do circle, square, circle, square, circle, square, that was a sequence because it followed a pattern. And it's a discrete function where the output is the number in the list and the input is the number's position in that list. So for example, the first term, that is the input, what number in the list you are. The output is the actual value. Okay. And the dots at the end means that it's infinite. So we can tell this is a sequence because it's adding 2 each time. That's the pattern. And the dots at the end is telling us it's going to go on forever. So just like functions, there's many types of sequences. Arithmetic sequences are when you add or subtract to get the next term. And this is like linear. Geometric is when you multiply or divide to get the next term. And this is like exponential. So arithmetic is just a discrete linear function. Geometric is just a discrete exponential function. And just like we had function notation, like f of x, where x was the input and f of x was the output, we have function notation here, or sequence notation. N tells us which term we're talking about. This is the input. This is where in the list you are. A sub n is the actual value of the term. This is the output. So if they ask for A sub 3, they're basically saying the third number in the list. Right here, n is 3. So if I go 1, 2, 3, A sub 3 equals 16. The third number in the list is 16. Here they're saying A sub n is 10. What is n? So in the list, where do we see 10? 10 is the second number in the list. So for this one, n is 2. A sub 5 would be 28. This says the fifth number in the list is 28. So the fifth number is 28. So we're going to start for arithmetic and identify the parameters. So A sub 1 represents the first term of the sequence. D represents the common difference. We have 2 types of rules. We have the explicit rule and the recursive rule. The explicit rule is very helpful if we want to calculate any term of the sequence, and it is our preferred rule. Recursive rule is used only if we know the previous term and we want to find the next term. It's not as useful, but it's not as useful in math, but it's very useful in computer science, which is why we look at it. So again, we'll be focusing on the parameters. A sub 1, filling it in both of them, what the first term of the sequence is, and then D, what we're adding each time. So let's do some examples. So they want us to find the first 4 terms of the sequence. This first rule is written in recursive format. Whenever you see like a comma here, that's a recursive rule. So the parameter A sub 1 is the first term of the sequence. So this sequence is going to start at 3. And then D, what's being added at the end, is your common difference. That's what's being added each time. So 3 plus 12 is 15. 15 plus 12 is 27. 27 plus 12 is 39. So those are the first 4 terms of the sequence. This next one's also in recursive format. So A sub 1, we're going to start at 10, and D is -1. So we're going to be subtracting 1 each time. So 10 minus 1 is 9, 9 minus 1 is 8, 8 minus 1 is 7. This next one is in explicit rule format. It matches the format here. So here, A sub 1 is at the end of the equation. D is at the beginning in front of the parentheses. So D for this problem is 4. That means we're adding 4 each time. And 3 is where we're going to start. So we're going to start at 3 and increase by 4. So those would be our first 4 terms. This next one, D is -6, so we're going to be subtracting 6. N is -2, so we're going to be starting at -2. -2, subtracting 6 each time. So the green numbers are our first term of the sequence. Our blue numbers are our common difference, how we get to the next term of each sequence. So to write the rules, you need to know your parameters. What is A sub 1? What is D? So A sub 1, the first term is 7. D, how to get to each next term, is you're subtracting 3. So in our rule, we're going to replace D, anywhere we see D, with -3, and anywhere we see A sub 1 with 7. So basically, you just rewrite everything else. So our explicit rule would be A sub n equals -3 times n minus 1 plus 7. So I just plugged in D and A sub 1. The recursive rule would be A sub n equals A sub n minus 1 plus D. Well, I guess it's -3 since it's -3. And then comma, A sub 1 equals 7. So again, all I did was in the formulas put in D where it belongs in the correct place, and 7, A sub 1, where it goes into the correct place. So when they want us to find a specific term, so they want the 30th number in this list. So if we kept going until we got to the 30th number, what would that value be? We are always going to use the explicit rule. And this is basically saying, let n be 30. So we need to set up our rule. So we need to know our 2 parameters. The first term is -7. The common difference is -2. So let's set up our explicit rule. A sub n equals -2 times n minus 1 minus 7. So again, I'm just putting in D into the correct spot of the explicit rule. And I'm putting in A sub 1 to the correct spot of the explicit rule. And if I want to find the 30th term, I'm going to do a sub 30 and plug in 30 for n. 30th term means n is 30. And so that's going to be negative 2 times 29 minus 7, which is negative 58 minus 7. So the 30th term will be negative 65. So if I kept this pattern going until I got to the 30th number in the list, that 30th number would be negative 65. So this one wants me to find a sub 12. So this is basically saying the 12th term or the 12th number in the list. So again, I'm going to use the explicit rule. So a sub 1 and d are the parameters I need to know. A sub 1 is a half. D is also a half. So the formula will be a sub n equals d times n minus 1 plus a sub 1. And I'm going to find the 12th term. So I'm plugging in 12 for n. So it's going to be 1/2 times 11 plus a half. So that's 11 halves plus a half, which is 12 halves, which is 6. So the 12th term of this sequence